This is section 4.3 of AB Calculus, page 9. Same idea as on page 8. We're going to sketch a graph of f of x. Down here on the bottom, that's what we're looking for, given the graph of f prime. Alright, same basic setup as on page 8. I've given you the zeros of f of x. Here's the graph of f prime. One slight change in that we have to look for more information off of this graph. We know from page 8 that we have to find the critical numbers. Of f of x, f prime equal to 0, f prime undefined, and f prime does not exist. And again, these guys aren't showing up just yet. I'll point that out, and that'll be clear when it finally does show up. All right, f prime equal to 0. This graph is f prime. So where does this graph equal 0? Equals 0 at x is negative 1. Also at x is 3. F prime undefined. Again, we're looking for these vertical asymptotes on the graph of f prime, or these slope values, these pieces getting very large positive or very large negative. So we see that at x equals negative 3. Now this did not show up on the last graph because I didn't want to throw too much at you all at once to look for. But from this point forward, we also need to look for possible points of inflection. And points of inflection come from where the second derivative is equal to 0, or that second derivative is undefined. Again, that does not exist situation, not showing up yet. All right, so we're looking for where f double prime is equal to 0. F double prime off of an f prime graph is horizontal tangents. For here, it's slopes. So where do we have a slope of 0 on this graph? That's occurring right here at x equals 1. And f double prime undefined, where we see some vertical pieces here, or slopes getting very negative or very positive, that's occurring at x equals negative 3. Now, looking at all of these numbers over here, that will set up our chart. And there are 2, 3, 4 of them. So when we set up the super chart down here, we will have x less than negative 3, x equals negative 3, negative 3 less than x less than negative 1, x equals negative 1, negative 1 up to 1, at 1, from 1 to 3, at 3, and finally x greater than 3. All right, again, filling in the columns here for f of x. The only thing we know about f of x are these zeros. And it's okay that some of them didn't show up in the table. That's fine. We'll take care of it when we draw the graph. We just have to make sure that we remember them. The only one that we have that shows up in this super chart here is at x is 1. All right, now let's look at f prime. And again, f prime talks about, when you're reading off an f prime graph, it's where is this graph above or beneath the x-axis. Well, we know the zeros here at negative 1 and at 3. And we know we have an undefined value for f prime at negative 3. All right, now let's just look. When x is less than negative 3, this graph, which is f prime, is positive. When x is between negative 3 and negative 1, this graph, f prime, is negative. When x is between negative 1 and 1, this graph is positive. At 1, be careful, it's not 0, positive. You're not looking at slopes here. You're looking at position to the x-axis here because we're reading the f prime graph from an f prime. We're reading the f prime column from an f prime graph. When x is greater than 1, still positive. And when x is greater than 3, all right, now f prime turns negative. What does this mean in terms of f of x? F of x is increasing here. An undefined is going to leave us toward a vertical tangent of some sort, either a cusp or that vertical tangent piece. F prime is negative, means that f of x is decreasing. Oh, here we have a horizontal tangent on f of x. Then f of x is increasing. F of x still increasing, increasing. At x is 3, f of x will have a horizontal tangent. And then when x is greater than 3, f of x is decreasing. All right, let's go back and identify our extreme values. Graph changing from increasing to decreasing, we will have a relative max on f of x. Graph changing from decreasing to increasing, that's a relative min. And f of x changing from increasing to decreasing, another relative max. Now let's go fill out f double prime. And let's see, first off, we know that at x is 1, f double prime is 0. And at x is negative 3, f double prime was undefined. All right, let's look here. F double prime is slopes of tangents of f prime. So when x is less than negative 3, slopes here are positive. For x between negative 3 and negative 1, slopes are positive. For at x is negative 1, slope is positive. Between negative 1 and 1, positive. For x between 1 and 3, those guys are negative slopes. At 3, negative, and greater than 3, still negative slopes. What does this column mean for f of x? That tells us about concavity. So f double prime positive means concave up. F double prime positive, concave up. Okay, right here, no change in concavity. So this vertical tangent here at x equals negative 3 is not a point of inflection. Concave up, concave up. Oh, here's a possible point of inflection. I'm going to look on the other side. That's concave down. All right, do we have a tangent line here? Yes, we do, because we knew that f prime is positive. I don't know how big it is, but there is a value there for f prime, which means there is a slope for the tangent line. So this point is a point of inflection. And we still have concave down here for f of x when x is 3, and concave down here. All right, let's sketch this graph. And don't forget about the zeros way up here. We need to see all the way out to x is negative 4 and x is 5. All right, let's go ahead and sketch this graph. We know we have zeros at negative 4, negative 2, 1, and 5. Have to hit the x-axis at those points, but nowhere else. All right, so now we start reading the chart. When x is less than negative 3, now negative 3 is right here. So to the left side of negative 3, the graph has to be increasing concave up. So increasing concave up. It has to pass through that point going into a vertical tangent relative maximum at negative 3. So increasing concave up, becoming vertical as x approaches -3. Then, for x between -3 and 1, the graph is decreasing, but still concave up. Now this is between -3 and -1, so all the way up to here, we have to be staying decreasing concave up. So maybe something like this. And coming into x is -1, oh, there's going to be a horizontal tangent. So that we can kind of take and flatten off here for our horizontal tangent at x is -1. Then for x, well, that's a relative minimum, good, so I got to start going up. Then for x between -1 and 1, increasing concave up, going to a point of inflection at x is 1. So increasing concave up, point of inflection at x equals 1. Then from 1 to 3, the graph is increasing concave down, and there is a horizontal tangent and maximum at 3. So increasing concave down, so we kind of turned here, increasing concave down to a horizontal tangent at x is 3. And then beyond 3, x is decreasing concave down. Make sure you hit this 5, 0 over here. Decreasing concave down. Okay, and the last thing that I would suggest you do is to kind of go back and just reiterate some of the things that we found. That this was a little vertical piece here by this cusp. We had a horizontal tangent right here. We had another horizontal tangent right here. And that spot is a point of inflection. All right? Thank you.